Hi Calcers, Mr. King here. I'm going to do a little tutorial here where I teach you how to solve a few tougher limits analytically. We didn't get to this in class, but I'd like you to see these so that you can possibly use them in your homework tonight. So the first limit is x goes to 3 of the square root of x plus 1 minus 2 over x minus 3. I think you can see that if you were to plug 3 in, we would have this situation blow up. Let's just see what happens. Square root of 3 plus 1 minus 2 divided by 3 minus 3. This is if we were to plug 3 in. We would get 0 in the denominator, and we would get the square root of 4 minus 2, which is 2 minus 2, which is also 0 in the denominator. That's an indeterminate form. So it looks like this limit probably doesn't exist because of this little analysis we've just looked at. But it turns out that this limit does exist, and I'm going to show you how to solve it. So a limit like this, where we have a radical in the numerator, can be handled if we do the following. We are going to multiply by the square root of x plus 1 plus 2 over itself, like that. And this is going to get rid of the radical in the numerator, as we'll see in a moment. Now, this has a nice form if we go back to algebra and we think about a minus b times a plus b. That's the form we have here, essentially. And that form is difference of squares if we've factored. So what we end up with here is this. The limit as x goes to 3 of the following. Well, the square root of x plus 1 times the square root of x plus 1 is simply x plus 1. The outer product and the inner product are opposites, so they wipe each other out. And we're left with negative 2 times 2, which is minus 4. X minus 3 in parentheses times square root of x plus 1 plus 2 in the denominator. And please do not expand the denominator in a problem like this. It will just cause you trouble. So at this point, we're going to simplify the numerator to start. We've got the limit as x goes to 3 of x minus 3. Notice that's the same factors as in the denominator. How about that? And the denominator again is x minus 3 times the square root of x plus 1 in parentheses plus 2, like that. Now we can divide the factors that are the same, the x minus 3's, which transforms this limit into the limit as x goes to 3 of 1, which is not 0, 1, divided by the square root of x plus 1 plus 2 in the denominator. Now at this point, we can see that if we substitute 3 directly in, we can evaluate this limit. And here's what we get. 1 divided by the square root of 3 plus 1 plus 2. And the square root of 3 plus 1 is the square root of 4, which is 2. And so that means we get a 2 for that. And 2 plus 2 is a 4. And there's a 1 in the numerator. And so this limit is equal to 1/4. If you can't believe this, I urge you to graph it on your calculator or computer and take a look at it. The limit as x goes to 3 of this function is 1/4. You could also look at the table in your calculator. So that's how you can tackle one of these guys. All right, here's our second, more difficult limit. And again, this limit says the limit as x goes to 0 of 1 over x plus 4 minus 1/4 divided by x. Well, if we were to let x go in as 0 right now, let's see what we would get. We would get 1/4 minus 1/4 in the numerator divided by 0, which is 0 over 0. And again, that's an indeterminate form, which means it appears that this limit does not exist. But once again, were we to graph this function and look at it, or look at the tabular values that we might see in a graphing calculator, we would see that this limit in fact does exist. That as we get closer and closer to 0, that is, x gets closer and closer to 0 from the left or from the right, this function does approach a limiting value, and this two-sided limit does exist. I'm going to show you how we can prove that. In this problem, the way we do it is we're going to combine both parts of the numerator. And to do this, I use something that I call cross multiplication. It's really just an algorithm. It's not really a proportion that we're solving here, but we can almost treat this minus sign here as if it were an equal sign when we do this. So here's how it works. I say the following. This is the limit as x goes to 0 of 4, because I did 4 times 1, divided by 4 times x plus 4. And you can see right away that that's the common denominator for the two fractions in the top, minus, and then I have to bring this x plus 4 and multiply by the 1, so there's an x plus 4 in that numerator, and the common denominator again is 4 times x plus 4. It's all divided by x, like that. Now we can do some combining, but be very careful. This minus sign right here distributes to the x and to the 4. So it looks like this. The limit as x goes to 0 of 4 minus x minus 4, all divided by 4 times x plus 4. That's the entire numerator, and all divided by x. Well, we're going to simplify the numerator, and these 4's eliminate each other, like so. And what we're going to get is this simplified form of the limit as x goes to 0 of a negative x over a 4 times x plus 4, all divided by x. Now, you may have been thinking that you could have come over here and saved yourself a step by dividing these up here at this level. And that's not okay. You can't do that. It's very important that each step of your analysis is perfectly, completely correct. And so we only wanted to show that the elimination of the 4's up here. So we had to bring down to the next line and show that we had this negative x. Now it's at this stage that we can divide this negative x by this positive x right here. Those divide, leaving us with the limit as x goes to 0 of negative 1 divided by 4 times x plus 4. And now we can let x go to 0 and evaluate. So this becomes negative 1, 4 times 0 plus 4, and that's 4 times 4, so 16. And this limit equals negative 1 over 16. And that's our value. And we're done. This limit does exist. I hope these two examples were instructive. You will need to be able to use both of these methods in your homework, no doubt, and possibly on a quiz or test. Good luck. King Calc over and out.